So you've seen something about how the big system works and what we can do with it. But the big system is expensive and hard to haul around, and there are only a few of them in the world. So we need, and there are many manuscripts that need work. So we need the capability to sort of have more people work on them to do studies. So this has significantly less capability. There's no fluorescence, there's no transmission. There's only reflection, and there are 16 bands of that, which is more than we had on the Archimedes, but gives us some useful results. These have been used in a variety of locations. There you see Izzy in Dubrovnik, where she's going to be 2 weeks from now for 9 months, using this system at the National Archives of Croatia. Buff State, Case Western Reserve, Washington University, St. Louis. These are only a few. There have been other places as well. This thing has a fairly broad response. We have a UV vis IR lens. We have a vis IR lens in it. There's the lens. That's the most expensive component in the whole system. The goal was to build this thing for about $7,000. The lens is about $2,000. It has its own software. The image collection, I would say, is probably the more difficult of the two, because you need to be able to interface to the different possible cameras that people can use. But and you've got to be able to run it on your computer. So we suggest specific computers for people to get. The processing software has to be able to run on Windows or iOS. And it's pretty basic, but also it's free.
For the process. So we have two options for different camera types. We have the FLIR camera and we have the pixeling camera. Different institutions are always more than welcome to add on another camera, but that means that they need to modify the code within the capturing software in order to make it work with the system. So you always can, get a better camera if you want to, but that requires additional coding, someone on your team with an understanding of software and computer science as well. And we have two different options for LEDs at the bottom. That's because our LED wavelengths, I believe, are hard-coded in, correct? Yeah, so they're hard-coded in to the software, and so we have kind of two different versions depending on what LEDs we have available. They're only about I think it's like two bands that are about 5 nanometers off from each other, so it's not a significant difference. But because they're hard-coded in, we would lose 2 bands if we only used one version or the other. So that's why there's 2 options. So whatever version of LEDs or camera that I have plugged in here, the software will automatically register with which camera I'm using, if I'm using FLIR camera or if I'm using our pixeling camera, and it will also register which LEDs I'm using as well. So I don't have to remember, oh, this is version 1 or version 2. It automatically comes up for me. We have a test LED button here. This goes through all of our visible wavelengths on the system. It's also nice to know to make sure that the LEDs are working and we're good to go for imaging. It's also fun for demos because you get to see pretty lights flashing.
Or the IR going on right now.
I can't turn it back on.
No.
The capturing isn't happening while this is happening.
Okay.
This is just testing the LEDs themselves.
But it's just the visible.
Yes, just the visible light.
Do you have IR on there too?
Yes, and I can go through that later on in the demo. This is just the beginning part.
Oh, you don't have to go through it now, you're just curious. So.
No, you're totally okay. I was going to go through the whole thing anyway, so. All right, so everything's pretty much automatically registered, so when I'm ready to begin capturing, I just hit start. And this is important for us museum studies people, specifically knowing the metadata of the object that we are imaging, how big the object is, what material it is, and then for our metadata system, we want to know the date on which this was imaged, the institution owner and title at a minimum, so that way for us as the people working in the lab, we can have, this will output as a TXT file, we can refer back to it if we want to go back to the curator, the archivist, the librarian of a collection, and say, hey, we have a question about this document that was in this collection, it was in this folio, or it was in this folder, it was in this box. And it helps us better communicate with the institutions, the archives, the libraries that we are working with. Again, we can add in the artist, the creation date of the object itself, all important information for us to know, to remember, okay, this object was this big, or this object was made with this material type, and that's just good data for us to know too. So how many objects are we imaging from this time period? How many objects are we imaging from this material type? That's all really good information for our team to have, to know what works and what doesn't work with the system. So usually for demos, I don't do anything fancy, so I'm just going to put in test. And we're in the carry collection, so I'll just put carry collection for now. And like I said, this outputs as a TXT file. Anything that's captured today all goes into one nice folder, and this will be one of the files that will be in that nice folder. So one of the first things we do before we even start focusing the camera, we work with a manual lens. Again, that was a cost thing, to keep costs down, to keep the system under $10,000. But one of the things we do beforehand is we capture a dark image, and this is to mitigate the noise in the camera. So we just keep our lens cap on, we hit start, and it's hopefully going to show a dark image. Yeah, there we go. And so this is also output as another separate file. And this is our dark image, and it will be incorporated into our final data cube, which is essentially all 16 images that we take in this capture section. They're all stacked on top of each other, and they're put into 255, so our black to white pixel values, and we're trying to get that histogram as wide as possible to make sure we're getting the most amount of data as possible as well. So once this is set up, if we're imaging a collection of objects around the same size, we can image easily up to 50 objects in a day, because the imaging process itself, like this, does not take very long at all. We'll be done in about a couple bands, and we'll have all of our captured data. So it's very easy.
You won't have processed data.
You want to process data, but in terms of captured data, you'll have everything. So this image is a little dark, because I couldn't set the exposure values. But if we go to this band here especially, you can see the undertext a little bit more than you could if you were looking at the object up front. You can see that it's just a tad bit more visible. There's more contrast between the medium and the text itself. And you can be able to go through all your bands and compare and contrast, make sure your images are to your liking. And then the final couple steps we have are capturing flats, which I will skip for time. And then once you're done, you're able to create your data cube. And so usually we have a calibration target with us, or a perfectly reflecting diffuser, or PRD. I didn't bring that with us because that's $100, and I was nervous something was going to happen to it. But it's usually a little white porcelain disc. It is 98.5% reflective across all wavelengths, and so we usually have it somewhere that's visible where it's not within any of the area that might block the undertext, for example. And so that's what we use for our calibration target. And then we can also crop the cube if we would like to. If we have, sometimes our objects are small enough where we have a border of just black space that we just want to crop out, so when we go to process, that extra black area doesn't get in the way of the statistical methods we use. And then once we're ready to go, we hit continue, and this will output out a header file, all of our 16 raw images, any of the 16 raw flat images that we capture, and then a TXT file, and it all outputs into one folder. And that is how MISHA works.
Very cool.
Very cool.
Keshav, do you have anything you'd like to add? Because this is your software.
You did a great job.
Are you sure? I feel like I really misexplained a couple of things, so I just really wanted to.
Yeah, you did a great job.
Keshav is the genius behind this, so I always defer to him for making sure I got everything, but no. Thank you.
Can you make it go through its thing one more time? I just want to get
absolutely.
Explaining the object.
It's in the same spot.
So here's the.
I can run it again if you'd like me to.